One, be attentive and carefully listen this one. So the first thing here you can see, okay, welcome my dear, welcome. You can see here the noble gases, you know very well. Actually, this you can see from your screen, and I will going to take my screen back. Okay, this one is not much clear, so I'm going to take it back on my book. Okay, my dear students, now here we're going to discuss about the noble gases. The noble gases, you know very well, belong to group 8. Okay, so the group 8 here in front of you. Now you can see the screen?
No, yes.
Now you can see. Okay, thank you very much. Okay, so here the first question, what do you call a chemical elements with no chemistry? It's little bit very unusual question in which we're going to discuss about that. So, but it's not mean it will be like this. Yes, please.
What is the question?
The question, you can't see the screen. It's written here. Here you can see the question from the screen that is written here.
What do you call it?
Yes. What do you call a chemical element with no chemistry? Okay, is it impossible a chemical, and chemistry mean it will not going to react, or it will not going to make any compound, or it's not going to do any kind of reaction. A noble gas, it's give you here the answer as a noble gas. What it's mean? A noble gas that you can see here. Now I'm going to just little bit zoom in. Sorry?
Noble gas is not reactive.
Yeah, not reactive. Very good. But why? The reason we should know the reason why a noble gas is not reactive and why we call this as a noble. Noble means basically a person who is not making problem, he is not going to fight, he is very good, he is with good manners and good ethics he has. Okay, basically we name this. The most striking thing about this family of elements is their lack of reactivity. Mean to say they are not going to react more. They used to be called the inert gases. Inert mean they will not going to react. Okay, inert mean having no reactions. You can underline and or even you can write this thing on your notebook. However, in 1962, their first compound was made. But keep it in your mind, in 1962, we or the scientists can created or made a compound with them in 1962. They were then renamed the noble gases. After that, we're going to rename them. We gave them name again as noble gases. So from here, as you know, I am going to give chance, Mr. Hussain. Please, can you read from here? Yes, as you know, most of the gases, please.
Do I open my mic or to be noisy?
You can open your mic.
The most striking thing about this family of elements is their lack of reactivity. They used to be called the inert gases. Inert means having no reaction. However, in 1962, their first compound was made. They were then renamed the noble gases.
Thank you very much. Okay, now you can see from here, as you know, most of the gases we have made so far are made up of molecules. Gases like oxygen, the chemical formula of oxygen in front of you, O2. This O2, that is meaning oxygen. Hydrogen, it is also H2. Okay, it is a gas. If a simple H, that means that one element. And if only O, that means this the oxygen, not molecule, only element form of oxygen. Now, and chlorine, Cl2. However, the noble gases are so unreactive. What it means? They are not going to react quickly, that they are found as atoms themselves. They are called monoatomic molecules or monoatomic gases. What it's mean? Mono mean, my dear student, mono mean one. What's the meaning of mono? One. So in their molecule or in their presence in the nature with one atom. So we call them monoatomic gases, one atom gas. The noble gases are very unreactive. So my dear students, till here, if you have any question, you can raise your hand, otherwise type no in the chat. Everyone, please. Okay, that's great. Thank you very much. Well done, my dear. They are replying me. Now, after that, I'm going to take you back on the PDF slide. Here you can see that the group of non-metals, we're going to discuss about them. Now here, the number of elements that present in this group, you can see here, group 8 elements are called noble gases or inert gases. You know very well, and you know why we call them inert or noble, because they are non-reactive, or if you want to react them, you need very extreme condition. Okay, so welcome Muhammad Nabil. Noble gases are also called monoatomic gases. So these are helium, He, neon, Ne, argon, Ar, Kr, krypton, X, xenon. These are their name, and Rn. Now, noble gases so unreactive or inert. Let's see the reason. Okay, here I'm going to tell you the reason behind their unreactivity. It tells us the first thing here, that is about the stability. What is the mean of stability? When a thing is stable. For example, if you are hungry, you need to eat food. After eating food, you feel yourself satisfied. Okay, maybe for 5 hours, for 6 hours, for 3 hours, you don't want to eat more, because that time after taking food, you become stable. You become stable. So yeah, so when you move, play, run, again you feel hungry because you digest your previous food and you wanna eat more. In the same way, here you can see the stability of atoms when an atom becomes stable, because the atom, you can say that there are 3 fundamental particles in an atom, that is proton, electron, and neutron. These 2 are present in the nucleus. Okay, and this, the electron, that is revolve around them. So that is present here. This is 1 electron and that one is the second electron. We here going to discuss about 2 rules. One we called as Duplet Rule and second is octet. In the Duplet Rule, the atoms who have outer shell and there he need to complete only 2 electrons. This type of filling or stability only 2 atoms want. One is hydrogen and second is helium, because helium outer shell contain 2 electrons maximum, and then this become stable. Outermost shell are completely full of electrons, so that become stable. Now the other all we name as octet rule. Octa mean 8. Octa mean 8. Like neon, argon, many other elements, they need to complete their octet. Octet means they need to complete 8 electrons in their outermost shell. So when 8 electrons are present in their outermost shell, they become stable. Understand about the stability? Okay, now after this, we move to the next. A simple class assessment. Okay, who know the answers, they can type in the chat about the stability. The first question here in front of you, noble gases are unreactive, mean to say stable. They are not going to react more. Now, the second thing here, outermost shell are dash full of electron. So no, this is not. Yes, this is the correct one. Well done, Mr. Zoom. Yes. Okay. So This one, the options are here. Their outermost shell partially full, mean to say half full, completely full, or ionic. So the best option, you know very well. In the first one, Riyad, what you gonna write? Nobel, no, Nobel is not even in the option. You can see down the option. Okay. But you need to type the answer. Well done, the students like Mr. Ahmad, Abdullah, Riyad, Ayad, and Mr. Saleh. Very nice, excellent. And Ali, very nice. Well done. The students, they join online. Please, you also participate. Very nice. Okay, the second assessment here, the second question from this first class assessment, you can see that is in front of you. Group 8 elements are called dash gases. You know very well. So number A is Nobel, number 2 halogens, and number C is alkali. So you know this one is option number A. Very nice. Now dash is used in killing bacteria in swimming pools. So that is also very easy for you to know. So you know very well, in the swimming pool, if the amount of which element is more, you feel burning in your eyes. So
chlorine.
Yeah.
Or they can call it for short chlorics.
Yes. But the actual is the option number B. Okay.
Chlorine.
Now, after this, I'm going to take you back on your textbook. So here, you know very well about these elements. Now, next, why are the noble gases so reactive? Or, you know, because they are stable. Why? Let's see this thing again. As I already explained you, now we're going to discuss from the textbook. Chemical reactions involves the electrons in the outermost shell of atom. Most atoms have a tendency to have their outer shell completely full of electron. With full outer shell, atoms are stable. You know which are these atoms very well. These are belonging from group 8. Atoms are give, take, or share electron with other atoms to get full outer shell. What they can do to complete their outer shell? Maybe they can lose, they can gain, or they can share their outermost shell with other atoms and become stable. So you can see here, helium, outermost shell, 2 electron, it means it's stable. Here, neon, 8 electron in the outermost shell, that is also stable. And the argon, also in the outermost shell, 8 electrons. The noble gases are stable because their outer shell are full. Very easy to understand this thing. Now let's move to the next page, page number 57, the physical properties of noble gases, how they behave physically. So the first thing here, boiling point. Do you think that it takes a lot of energy to boil a noble gas? Because you need high temperature. It means that what evidence have you got for your answer? By the time we get to room temperature, the noble gases have already boiled at much lower temperature in general. The force between molecules gets stronger as the molecules get larger. Very easy to understand. So what do you think happened to the boiling point or boiling temperature of the noble gas? So here in the, you can say that highlighted form, the boiling point or boiling temperature of noble gas increase going down the group. When you move in the group from top to bottom, their boiling point going to increases. This is also very easy to understand. Now next is about the density that you already discussed about in the halogens. We know very well about this. So about density, what it's going to tell us, how would you expect the density of the noble gases to change as we go down the group? Can you think why? Look at the graph opposite. Here, helium, neon, argon, krypton, xenon, and R and radon, they are present in front of you. It means they are increasing down the group, their weight, their density going to increase from top to bottom.
If I had like a cup of water,
Yeah.
if I took a hydrogen, if it was like we made hydrogen a liquid.
Okay.
Would it be heavier?
Yeah. It's two options here. You going to find the density with compared to other. Okay. First of all, you know the density of water. Okay. If the thing, anything, not even hydrogen, chlorine, bromine, any helium, neon, anything you want to put in the water, you know the both density. Which one is denser or heavier? It will sink to the lighter one. Okay.
Like mercury, when you put it in the like videos, when you put mercury, it's denser than water, so
it will go down. Like for example, iron is denser than water. That's the reason it will sink down in the water. But the wood is less dense or lighter than the water. So that's the wood float on the surface of the water.
Anything that's less or dense will sink or...
Yes, it's just a compare between two things. When you're going to comparison, which one is the denser one, it will sink. If it's lighter than that thing, it will float on the surface.
They say that gold is light.
You can do the experiment when you're going to find. Now come back to your next page on your textbook. That is about the helium, and we use in different ways the helium in the hospitals to find out different types of tumors and neon. And also after that, here the uses of in the air balloon, in the hydrogen is not safe to use as airships. In the airships we use this. And the last here about neon, argon and krypton. So before to go and read them, I'm going to share again the PDF file. You can see here about one by one. Uses of helium. Where and how can we use this helium? It is used in airships, weather balloons. You know that at, yes, please. Yeah, no problem, you can. So the balloons in which people are moving, the big one, so this use the helium gas. It is used in body scanner instrument, as I just show you from your textbook page. So you can use this. The uses of neon, it is used in red signs like traffic signals, you know very well. The use of bromine, it is used in pesticide, because I missed this, so I put this here. And it is used in to make medicines. It is used in photographic films. Next, uses of iodine. Iodine is used in antiseptics. Now come back to argon. This from group 8. It is filled in the light bulbs. It provides inert atmosphere in welding. It is used in extraction of titanium. Metal, used of radon. Radon is radioactive and is used to treat cancer. The krypton, it is used in laser to operate eyes. So after this, we move to again another assessment. So please, who know the answers, type in the chat. There are almost 4 questions. So take your time, read this well, and then reply. Just type in the chat. Well done, very nice. Dash is used in airship. Okay, type here, no problem. Well done. Dash is used in red signs, traffic signals. Very good. Well done, my dear. Dash is radioactive and is used to treat cancer. Okay, well done. The last question. Dash is used in laser to operate eye.
Mr. How laser. Mr.
Yes, as a laser, you know.
The laser for someone who has less.
These are, you can say that as rays, yes. Okay, very nice. Well done. Type in the chat. Very good. Excellent, my dear students. The students, they are participated like Abdullah, Hatim, Ayad, Riyad, and then what? Ali Azib, yes. What about the other student? Mashallah, we have more than 23 students here. Umar Qasim, Abdullah Tariq, Abdul Malik Faisal. I didn't find your answers. Please, everyone. Muhammad Al-Tom, please, my dear, you should also reply. Muhammad Nabil, not replying. Please, everyone. Okay, very nice.